All right, so in this example, we're working with, again, we're going to work with Venn diagrams, and we're working with some information about the students in our class. So again, we have 29 students enrolled in this class, but now we're given some different information. We're told that 9 are sophomores. Okay, so that's different. We had freshmen before. 16 are business majors. Okay, we already knew that. And 10 are female. Okay, so we can actually start drawing our Venn diagram because those are our 3 categories. We have a category of students who are sophomores and some who are business majors and some who are female. Some may be any combination of those things. So let's start by drawing our Venn diagram. So I'm going to do it just like I did before. I'm going to draw a circle representing each category. Whoops, trying to get my pen going. So we have a circle representing the set of all sophomores. So I'm going to call it S. And then we have business majors. So I'm going to call that circle B. And then we also have a set of students who are female. So I'm going to call that set F. And then I'm just going to draw a big box around the whole thing to represent the whole class. Okay, so this represents the whole 29 students who are in this class. All right, and now let's just start putting some of the information that we're given in on the Venn diagram. So I already put down the 29 because that's the set of students in this class. We were told that 9 are sophomores, right? So I'm just going to write 9 here. I write it on the line because I don't know how to split it up between the regions. So you can see now we have the sophomore circle is broken up into 4 regions. You know, we have some people who are only sophomores but not business majors or female. We have some that are both sophomores and business majors, some that are both sophomores and freshmen, or sophomores and females, and then we have some that are all 3. So we have 4 regions. We don't really know how to break up that 9 yet, so I'm putting it on the line. All right, we're told that there are 16 business majors, and we have 10 females in the class. Okay, now we have some other information because given that we really don't, again, we still don't know how to break up the information, you know, all these students into these other regions. So we're also given that 2 female students are business majors. Okay, so there are 2 people who are in both the business major category and females. Now, we don't know that some of those 2 people might also be in the sophomore category, but we're not given anything about sophomore. We only know that there are 2 people who are female and business majors. So again, I'm going to write it on the line because I really don't know how to break it up. This region right here represents the people who are female and business majors, but part of that region, some people in that region might be sophomores and female and business majors, and some might be business majors and freshmen, but not, business majors and female, but not sophomores. I should probably write that down here. I keep thinking F is, because we defined F as female before, so I'll just call it female. I'll write it all out. I'll write this as sophomore so we don't forget what we're doing here. Business majors. Okay. All right, so the next piece of information says that 4 female students are sophomores. Okay, so there are 4 people who are both sophomores and female. Again, that region is represented right here. Maybe I should use a different color. So this is the region right here, but we have 2 parts to it. So we really don't know how to split it up yet. So I'm just going to put 4 on the line. And then we have 5 sophomores who are business majors. Okay, so again, this region, this overlap between sophomores and business majors represents that group, but we don't know how to split it up, so I'm just going to write 5 here, right on the line. And then the last piece of information says that 1 female student is a sophomore business major. Okay, so that's telling us there's 1 in this overlap between all 3 of the sets. Okay, now from there we can go and figure out a lot of stuff, right? Because now we have this group. We had this group that we had the 5 sophomores who are business majors, right? And we've already now accounted for 1 who's also female. So there have to be 4 students who are sophomore business majors but not female, okay? Because the whole group has to add up to 5. So we can just kind of keep working our way around the circle. We had 4 sophomore females. One of them is a business major, so 3 of them are not business majors because the whole amount, this whole group has to add up to 4. And then finally we had 2 female business majors. One of them is a sophomore, so that means one of them is not. So so there we have it all. We have that all figured out. And we can just keep working out from the center. So now I know there are 9 sophomores, right? Now if I add up the number that I have accounted for already, I've got 4 sophomore business majors but not females. I got 1 sophomore business major female, and I have 3 female sophomores. That accounts for 8 right there. Right? 3 plus 1 plus 4 is 8. So that means one person has to be a sophomore, but not a business major or a female. Okay? And again, we can just keep working our way around the circles. So I know that there are 16 business majors. 4 are also sophomores, but not female. 1 is all 3, and 1 is a female business major, but not a sophomore. All right, so I have 6 accounted for. 4 plus 1 plus 1 is 6. So I can subtract that from the 16. That means 10 business majors in the class are not sophomores and not females. Okay. And again, down here with the females, we know we had 10 females. We have 5 accounted for already. So there have to be 5 females who are not sophomores or business majors. Okay. Now we can actually figure out how many people are in the whole group of sophomore business majors and females. So that's a useful piece of information, because what we're looking for are those that are not sophomores, not business majors, nor females. So we're actually looking for this number out here. But we need to know how many are inside the circles in order to figure out how many are outside the circles. All right, so we need to add up the numbers that are just inside the circles, not the numbers we wrote on the lines, right? Because those were numbers we just didn't know how to break them up yet. So I'm going to use the highlighter here. We're going to need to add up these numbers, just the numbers that we've written in the spaces. Okay, none of the numbers that we've written on the lines. Okay, so if we add up those numbers. Now, one little tip as far as adding these numbers. I already know, like 16, there are 16 business majors. So the numbers inside the circle for the business majors, I know already adds up to 16. So I'm gonna start with 16. And then I'm just going to add the other 3 numbers that are outside the business major circle, but still inside the female and sophomore circle. So I have 5 plus 3 plus 1. Okay, so that gives us 25. Okay, so what does that number represent? That is the number of elements in the union of S and B and F. Okay, the number of elements, number of students in this case, because our elements are students. The number of students who are sophomores, or remember we're gonna read this as or, business majors, or females. Okay, so we can write that as the number, because we wanted to calculate the number of. So the number of students who are sophomores, business majors, or females is 25. All right, so if they're not sophomores or business majors or females, which is what we're looking for, that's just the complement of what is in the union of those sets. Okay, so in order to figure out the question we're asked for how many are not sophomores, business majors, nor female, we're just going to take 29, which is the number of students in the whole class, and subtract the ones that we know are one of those categories. And so we have 4 students who are not sophomores, business majors, or female. So that would be our final answer for that question. All right, so I think I have a couple more examples to go through. Now, in your book, they have some equations, which I recommend that you don't worry about memorizing. I just put them here, but don't memorize these formulas. I want you to reason it out. That's kind of why I decided, I'm starting with 6.2. Because I think that if you start with all that set notation and set operations, then start trying to apply formulas instead of thinking it through. I want you to keep your thinking caps on when you're doing these problems. Think it through. They're just, like I said, yeah. Don't memorize. I want you to think and understand. All right, so I got a couple more examples that I'm going to go through. I would say look ahead and try them yourself, and then we'll go through them. I'll record videos for you to try them for you to watch if you have trouble with them.